Okay, so number 5 is just like number 4, lots of neighbors. I am going to add the opposite here and decide which two do I want to multiply first. I'm going to go with these. I just like the x and the x going. So x visits, and you get x squared and negative 6x. And then 5 visits, 5x will stack with the negative 6x, and then you get the negative 30. So when you combine these, we get x squared, negative 1x, and negative 30. And now this group wants to meet the other neighbors, and I will have negative 2x do the visiting first. So it's going to visit all these people, and you're going to get negative 2x cubed. When they meet, they're going to get 2x squared, and when these meet, I'm going to get 60x. And now 4 is going to visit everybody. So 4 meets, and you get 4x squared. 4 meets this person, you get negative 4x. And 4 meets this one, and you get negative 120. And again, not a lot of room for my answer, so I'm going to put it over here. So my answer is, I'm going to put it right up here, add my x cubes, add my x's, or x squared, sorry, add my x's, it's 56, and then the negative 120 just comes along. All right, so when you get to 7, 8, 9, these are not neighbors visiting neighbors. This is subtraction, subtraction, and addition. So when we do subtraction, it's better to turn it into addition. So I'm going to go left to right. And when I get to this subtraction, this subtracts to everything in here. It distributes to here, 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 and here. So I'm going to go through and I'm going to add. I'm going to take the opposite, turn that into positive. Take the opposite, turn that into addition. Make that negative, and make that addition. And now I'll do what I did on problems 3, 4, 5, and 6. I'm going to combine my like terms. So 7x cubed and 3x cubed now is 10x cubed. I'll go for the x squareds because again we're going for our answers in standard form. This is the only x squared, so 2x squared. My x's will be next. There's 5 of those. And then I'll finish with the 3 and the 7, and that gives me 10. Okay, so number 8, another subtraction problem. All right, so going left to right, adding the opposite. Oh, there's supposed to be a number there, and it's cut off, and I really don't know what it is because I only have this 3-hole punched. So, geez, I'm sure all of ours are like that. So let's just put a number there. Let's put this is minus 5. So I didn't even know that happened. All right, so I'm going to go through and I'm going to add the opposite left to right. So this minus only applies to this. I'm going to add the opposite. And then when I get to this one, the subtraction applies to everything in here, up including that new 5. And I'm going to add, I'm going to make the opposite of this negative. The opposite of this is negative. The opposite of this is negative. Maybe you want a 1 there. And the opposite of subtracting is adding. So remember, when you do the opposite, we're only changing one thing about each of these. Okay? So we're going to combine our x cubes first. They're the highest power. And we're going to have 3 of them. Then we're going to go for our x squareds, and negative 2 and negative 3 gives us negative 5 of them. Then we can go for our x's. 5 and negative 1 give us 4. And then negative 4 and this 5 will give us 1. So number 9 is addition. Adding the opposite is going to be pretty safe. Left to right, add the opposite, add the opposite. The addition doesn't, we don't have to worry about to each thing. And here's add the opposite. So I'm going to start with my 4th powers. They are the highest. 4 and 3 is 1x to the 4th. You don't need the 1. I'm going to go for my cubes next. 7 and negative 3 is 4 of them. Then I'm going to go for my x squareds. Here's 1. So I have 2 of them. Then my x's. And again, that's like a 1x, so 8 and 1 is 9 of them. And then the final numbers 4 and 2 would give me 6. All right, now we're getting to the division problem, your favorite. So can you do synthetic division or not? I'm going to do long division. I'm going to add the opposite, put a 1 here. I'm going to add the opposite and put 1s here. I want to make sure they are in standard form, highest power to lowest power, and all the x's. So 4, 3, 2, 1, I'm good. 2, 1, the constant, I'm good. So what we're dividing is going to go in the box. And remember, we leave out the addition sign, so here's 3x to the 4th, negative 1x cubed, here's 8x squared, here's 5x, and here's 3. Sorry, you couldn't see that. And then outside of the box is what we're going to divide by. Again, I'm going to leave out the addition signs, x squared, negative 1x, and 3. And we start by underlining the first term in each set. And we want to see what do we have to multiply x squared by to make it 3x to the fourth. So again, we can put a 1 here. So 1 times 3 gives me 3. And to get from x squared to x to the fourth, I need 2 more x's. So I'm going to multiply by 3 and x squared. And when I put that over here, I'm going to put that above my other x squared. And then I'm going to draw these loops once, because now 3x squared is going to multiply to this, this, and this. So when it multiplies to this, I get 3x to the fourth. When it multiplies to this, I get negative 3x to the third. And when it multiplies to this, I get 9x. And remember, in division, you're supposed to subtract. So I'm supposed to subtract all of this. But then I pick up my other color, and this is what some of you are forgetting to do. And I add the opposite, and the opposite, and I'm just going to add the 3 columns. So when I add my x to the fourth, 3 and negative 3 cancel out. 3 and negative 1 is 2. And negative 9 and 8 is negative 1. I forgot the squared there. And now the others come down. And then I start over. So I'm going to underline my first term. So what do you have to multiply 1x squared by to get to 2x cubed? Well, to get from 1 to 2, I need to multiply by 2. I'll put that up there. And I have 2 x's, but I need 3, so I'm going to need 1 more x. And now this 2x is going to follow those 3 loops and multiply to those 3. So when I multiply these, I get 2 and x cubed. And when I multiply these, I get negative 2 with x squared. And when I multiply this, I get 6 with the x. So I'm going to subtract them all. But then I'm going to take my other color and go through and add the opposite, 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 and add them up. So 2 and negative 2 will cancel out. 2 and negative 1 will give me 1. 5 and negative 6 will give me negative 1. And I bring the 3 down, and I do this one more time. So what do I have to multiply 1x squared by to make it 1x squared? I already have it, so I do have to multiply it by something. I have to multiply it by 1. The 1's going to multiply to all 3 of these, so 1 with this is 1x squared. 1 with that is negative 1x. And 1 with 3 is the 3. You subtract them all. And if you go through and do that, add the opposite, opposite, opposite. 1 and negative 1 cancel out. Negative 1 and 1 cancel out. 3 and negative 3 cancel out. So we get a remainder of 0. And remember, we're not just dividing to divide. We're dividing because after break we want to see if this is a factor of this. And it is, because we get a remainder of 0. So we're going to write our answer as our quotient. That's what's on top. And multiply it by what we divided by. You can put the ones there or not. And there is no remainder. If you want to add 0, you can, but you don't need to. So there's your final answer for 10. And you need to make sure you write the answer. This is not done. This is done. All right, let's go to 11. So when I look at 11, this is actually a problem I can use synthetic division, which we all love. All right, so I'm going to add the opposite. It is in standard form, but I am missing my x term, so I'll have to put a placeholder in. So I'll put 1, negative 2, 0 for my placeholder, and negative 4. And remember, we're going to take the opposite of this number. And I'm going to start with bringing the 1 down. 1 times 2 is 2. Add those up. 2 times 0 is 0. Add those up. 2 times 0 is 0. Add those up, and I get negative 4. So is this a factor? Is x plus negative 2 a factor? It's not. Because one thing this means is if x is 2, that y is negative 4. And in order to be a factor, it has to hit the x-axis, and this doesn't. This is somewhere over here. So this negative 4 has 2 jobs. One, it's a point on this shape when we graph it, but it's also saying that this is a remainder. And so over on this side is our remainder, on this side is our quotient, and we're going to write this as, this is the constant, and then when you get over here, this is a constant, this is x and x squared. So when you write your answer, it's going to be your quotient, which is just x squared, times what we divided by. And then we're going to add our remainder. And if you do this, look, there's x cubed, there's negative 2x squared, and then eventually I'd add on the remainder of negative 4 and you get what you started with. All right, number 12, we can also do synthetic division because it's a 1 and x minus 1. So make your upside down division box. 4, 3, 2, 1. I got my constant, so no placeholders are needed. And we're going to also take the opposite of this. And we start, bring the number down. 1 times 7 is 7. There's 5. Multiply, there's 5. Add them up is 8. Multiply, that's 8. Add them up again, that's 11. 11 and 1 is 11. And when we're done, we get 8. So again, we do not have a factor. This is not a factor of this. It means two things. One, if x is 1, your y is 8. And in this graph, that'd be like up here. And to be a factor, it has to hit the x axis. That's what we're trying to see. Can we get, if x is 1, for y to be 0? Can it be here? And it's not. So as far as division goes, this 8 is saying it's a remainder. Over here is the quotient, and I'm going to start with the constant x, x squared, and x cubed. And now I write my answer as my quotient. With what I divided by, and I add my remainder. And on the test, if I want to see if I am correct, now I think maybe I made a mistake here, because if I take 1 times negative 1, I get negative 1, and if I add on the 8, I don't get the negative 3. So I'm going to pause this, and I will fix this mistake and come back and figure out, but maybe you guys already saw it, so hold on.